To wrap up section 3.3, I want to talk about another important use of trees, which is in computer science. We talk about trying to find a traversal in a tree. Now, a traversal is just some process by which we visit every vertex or node in a tree exactly once. And I want to point out here that this sounds in a way sort of like it's a Hamiltonian path, right? Visiting every vertex exactly once sounds Hamiltonian. But a traversal is different from a path, and that it doesn't even necessarily have to be a path. So a traversal, it could be, but it is not necessarily a path. And what I mean by that is we don't have to travel along edges in our graph. So a possible traversal of this graph here would be the listing of vertices A, and then B, and then C. Right? It's some process of visiting every single node exactly once, but it's not a path because there's no way to get from B to C. There's no edge connecting B and C. So this is a traversal, but not a path. As opposed to something like BAC, which is a traversal and also happens to be a Hamiltonian path. Okay, but keep in mind, both times we're visiting every vertex exactly once. It's just that with a traversal, we don't necessarily have to travel along edges. Now, this comes up in computer science because sometimes you have to, maybe you have a bunch of files that you're trying to check and you want to make sure that your program checks every single possible file and doesn't miss any. And so you want some sort of an algorithm, some sort of systematic way to make sure that you're visiting every single node exactly one time. And there's a lot of different traversals or algorithms for traversals that you could use. In this class, we're just going to talk about two of them, the Preorder Traversal and the Inorder Traversal. So let's talk about the Preorder Traversal first. So the idea is that we're using this sort of recursive algorithm here that says every time we're going to follow these steps. Visit the root node. So the root node is just some fixed node. We usually think about it as being the top of our tree. Traverse the left subtree, traverse the right subtree. Okay, now this tree here is what we call a binary tree because at each particular level it's splitting off in two ways or possibly just one way or possibly just 0 ways. And so we can generalize these traversals to non-binary trees as well, but we'll only talk about the binary case. So let's go through and see if we follow the preorder traversal, if we follow this particular algorithm, in what order is it going to visit all of these different vertices? So it tells us that we need to start with the root node. So our root node is this one at the top, A. We visit it, that means that we're printing it, right? We're listing it. So we start with the root node, then we traverse the left subtree whenever possible. So that means our next one we would visit is B. Okay, so we've only really followed the first two steps for A here, and now we're at B, and we start again from the top. It says visit the root node of this subtree. So visit this vertex here, that's B. Then traverse the left subtree if possible. We can go left, so we go down here to D, and we start at the beginning. Visit that root node D. Okay, then traverse the left subtree. Oh, we can't, there is no left subtree. So we move on to the next step, traverse the right subtree. Can't, there is no right subtree. Fine. Okay, so we sort of reached a dead end here, and we go back a step to B and follow the step that we haven't yet done, which is traversing the right subtree. Right, so far at B, we've visited it, we've traversed left, so now we go back and traverse right. That means E is going to be next. We traverse the left subtree, that gives us F. There's nowhere to go from here, so go back and traverse the right subtree, that's G. And now we've run out of pretty much everything on this left subtree stemming from A. So we got to go all the way back up to A and follow the step 3, which would be to traverse the right subtree. That's going to give us C. So in the end, when we use the preorder traversal, we visit the vertices in the order A, B, D, E, F, G, C. So essentially with preorder traversal, what we're doing is we're going left as far as possible, and if we can't go left anymore, go right. And if you can't go left or right, then go up a level and just repeat that process. So there's something that really is recursive here in this algorithm. Now, Inorder Traversal is sort of the same rules, but they're mixed up a little bit. It's saying what you're going to do is you're always going to traverse left as far as you can. So start in anywhere you start. So if we start at A, we traverse left as far as we can, and then when we can't traverse left anymore, that's when we move on to step 2 of visiting the root node, that node whatever one you're on, and then traversing the right subtree. So let me use a different color here. Right, so the first thing we do is traverse left. So we start up at A, we traverse left, okay, and again, we can still traverse left. So we go left as far as we can. Now I can't go left anymore, which means I move on to step 2, which is visit that root node, D. Now I would go right if I could. Well, I can't. There's nothing to do here. Okay, so I go back up here, and because I've already traversed left from B, my next step would be to visit that root node B, and then traverse right. Okay, now I've reached E for the first time, but remember the rule is to go left as far as you can, so I go to the left. I can't go any further down, so I visit that F node. I go back up. Whoops, I can't go right. Okay, so go back up to E. We've traversed the left subtree already, so now we're going to print E and go to the right. And print G because there's nothing to do below that. Okay, so we've followed the steps here for all of these vertices B, D, E, F, and G, which means we go back up to A, we follow step 2, which is to visit the root node, and then traverse the right subtree, giving us C. Okay. So with the Inorder Traversal, it essentially says go left as far as you can, and when you reach a dead end, you visit that node, or when you can't go left anymore, you visit that node, and then go right. Okay, so we'll do this one more example on a slightly more complicated graph. Notice though that in both cases, we end up with a list of all the vertices of our tree exactly one time. Okay, so let's look at a slightly bigger tree and try another example. We're going to start with the Preorder Traversal, and then we'll go through and do the Inorder Traversal. So Preorder Traversal, remember, says visit the root, then visit the left subtree, then the right subtree. So we visit the root first, that's A, then the left subtree, that's B, then I can still go left, so I'd go D. Now I can't go left anymore, so I go to the right subtree, which is F. Now I can't go left or right anymore, so I have to go up a level. I've already done the steps here, go back up to B. I can't go right, so go back up to A and go right. So C would be my next vertex. From C, I cannot go left, so I go right. Then print E. Then I go left as far as possible and left as far as possible, so I visit G and then I. Go back up and go to the right, gives us J. Now I have to go all the way back up to E and visit the right subtree, so I visit H, and then finally the last one I can visit is K. So the Preorder Traversal is going to give us the vertices A, B, D, F, C, E, G, I, J, H, K. Okay. So for Inorder Traversal, we start at the root and we go left as far as possible. So I would go left again. I can't go left anymore, so I visit this, D, and then I go right. Okay, now I'm at right. I would need to go left if I can, so I can't. So I print F. I can't go right. So I need to go back. I've already done all the steps for F. I've already done all the steps for D. Go back up to B. And now I would go right if I could, but there's nowhere to go. So I go back up. I print A. And then I traverse the right subtree. So I start with C. I would go left if I could, but I can't. So now I print C and then go to the right. Now I'm at E. Go left if you can. Go left if you can. That brings me down to I. I can't go left. Well, so I print I. Can't go right, and I go back to G. I go to the right. I can't go left, so I print J. I can't go right, so I go all the way back up to E. Finally, I go to the right for H. If I could go left, I would, but I can't, so I print H. And then finally go to the right, and all that's left is to print K at the end. Okay, so this gives me the Inorder traversal of the tree. So we'll do a few more practice problems on the exercises.